artificial intelligence. The name itself sounds so straightforward, right? But underneath that simple term are some of the biggest, most mind-bending questions you can imagine. Like, if a machine acts smart, does that mean it actually is smart? Does it have a mind? Or is what we call consciousness just a super complex computer program? Well, that's what we're going to dig into today, the deep philosophy at the very core of AI.
Yeah, this one question, it's the big one. It's been hanging over computer science since day one. And we're not just talking about code and circuits here. Nope, this goes way deeper. It's about what thinking even is. And believe me, this single question sets the stage for everything else we're about to get into.
So, okay, if you're going to build a thinking machine, how on earth do you prove it's actually thinking? I mean, you can't just ask it, right? This is where the legend Alan Turing, basically the father of computer science, comes in with this absolutely elegant idea. He figured, hey, instead of getting stuck in an endless argument about what thought is, let's just create a practical test that cuts right through all the philosophical noise.
He first called it the Imitation game, which is a great name, but you probably know it as the Turing Test. And the concept, it's beautifully simple. The whole idea is, if a machine can chat with you, and it's so good at it that you honestly can't tell if you're talking to a person or a computer, then hey, for all intents and purposes, it passes the test. It's intelligent.
All right, so here's the setup. Picture this. You've got a judge or an interrogator sitting at a terminal. They're typing questions to two players they can't see. Player A is a real person, player B is the machine we're testing. The interrogator's whole job is to figure out who's who, just from their typed replies. And if after a good long chat they can't reliably tell the difference, boom, the computer passes. See, it's all about what it does, not what's going on inside its head.
And that right there, that's the core of Turing's whole philosophy. He wasn't interested in getting tangled up in these unprovable, abstract ideas like, does it have a soul, or is it conscious? His point was much more down to earth. You know the saying, handsome is as handsome does? Well, for Turing, it was, intelligent is as intelligent does. If it acts intelligent, then it is intelligent. Simple as that. Okay, so that's the theory. Sounds pretty straightforward. But the big question is, has any machine actually pulled it off? Has anything ever passed the Turing test? Well, let's talk about a very famous example, a chatbot named Eugene Goostman. Its claim to fame? It supposedly passed the test by pretending to be a 13-year-old kid from Ukraine.
And get this, a full third of the judges, 10 out of 30, were totally fooled. They walked away convinced they were chatting with a real human. That's not nothing, right? So what was Eugene's secret? Was it a super genius AI? Well, not exactly. The strategy was actually less about genuine intelligence and more about being really good at dodging questions.
Let me show you what I mean. Here's a little snippet from one of the conversations. The judge kicks things off with a super basic know it or you don't kind of question. Should be an easy one.
But check out Eugene's answer. It doesn't give a straight answer at all. Instead, it cracks a joke, throws in a smiley face. It completely deflects. And you know what? That's a very human thing to do, isn't it? When you don't know the answer, you change the subject or try to be funny.
So the judge is thinking, that was a bit weird. They can tell something's a little fishy, so they push back. They try to pin Eugene down with another simple, direct question. This is a real make-or-break moment.
And there it is, the exact same joke again. And that's the dead giveaway, right? This isn't thinking on the fly, it's a pattern. It's just a pre-written script that kicks in whenever it gets a question it doesn't have an answer for. That little sarcastic comment at the end, just more smoke and mirrors. And this whole exchange just perfectly highlights one of the biggest knocks against the Turing test. What is it really testing for? Is it measuring actual intelligence, or just how well a machine can fake being human, complete with all our weird quirks, our mistakes, and our ways of avoiding questions? I mean, is pulling off a good deception the same thing as genuine thought? This very problem, the whole fooling versus thinking debate, is what led the philosopher John Searle to come up with one of the most brilliant and famous counter-arguments in the entire history of AI. He called it the Chinese room thought experiment.
Okay, so I want you to imagine this. You're sitting alone in a locked room. You don't speak or read a single word of Chinese, not one. Now someone starts slipping pieces of paper with Chinese characters on them under the door. But you have a secret weapon, a massive book of rules all in English. The book just says stuff like, if you see this squiggle, then find the paper with that squiggle and pass it back out. You're not translating anything, you're just matching symbols. You have zero idea what any of it means.
Now here's the crazy part.
To the person on the outside who does speak Chinese, it looks like they're having a totally fluent, intelligent conversation with you. Your answers are perfect. They think you're a native speaker. But you, inside that room, you are completely in the dark. You don't understand the questions you're being asked, and you sure as heck don't understand the answers you're sending back. And that is the punchline of Searle's whole argument. He says that the person in that room is doing the exact same thing a computer does. It's just manipulating symbols according to a set of rules, that's syntax. It has no grasp of the actual meaning, the semantics. In other words, following a program, no matter how complex, is not the same thing as real understanding.
So what we have here is this incredible clash of ideas, right? You've got Turing, who says acting smart is being smart. And then you have Searle, who says, whoa, not so fast. Acting and understanding are two totally different things. But this isn't just some abstract debate for philosophers. It actually gives us the perfect vocabulary to talk about the different kinds of AI we have in the real world right now.
Let's make this super concrete. Think about a self-driving car. It gets to a red light and it stops. It's acting intelligently, for sure. Why? Because it's following a rule in its code. If light equals red, then apply brakes. But a human driver, we stop too, but we understand why. We know that running a red light is dangerous, that it breaks a rule we've all agreed to for safety. We get the whole context. That's the difference Searle was talking about. And this whole debate brings us to two really important terms you hear all the time: weak AI and strong AI. Weak AI is basically any system that just simulates thinking. It can act intelligently, but it's all about behavior, exactly what the Turing Test looks for. And guess what? This is every single AI that exists today, all of it. Strong AI, on the other hand, that's the dream. That's a machine with a real, conscious mind that genuinely understands things. That's Searle's benchmark, and for now, it's pure science fiction. Okay, so weak versus strong AI. That's all about the depth or the quality of a machine's mind. But there's another really critical way we categorize AI, and this one is all about its breadth, like how many different things can it do.
And here's the thing. Pretty much every single piece of AI you've ever interacted with is what we call narrow AI. It's designed to do one thing and one thing only. You have an AI that's a god at chess, but it can't even tell you what a cat looks like. You have another that can translate languages perfectly, but it can't play tic-tac-toe. They are absolute geniuses in their one little box, but they can't step outside of it. The holy grail is artificial general intelligence, or AGI. That would be one AI that could do, well, anything a human can do intellectually. And yeah, that's still way, way off in the future.
Now, it's important to remember that not everybody who works in AI stays up at night worrying about this stuff. You have guys like John McCarthy, literally one of the founding fathers of the field, who was way more practical about it. His take, and the take of many researchers today, is basically, look, who cares if it's conscious? Let's just focus on building amazing tools that can actually help us solve problems. So, let's just recap where we've landed. On one side, you have Turing's practical approach. If it acts smart, count it as smart. On the other side, you have Searle's big challenge. Nope, acting and really understanding are worlds apart. And then we have the reality on the ground today. All of our current AIs, what we call weak and narrow. They are unbelievably powerful tools for specific tasks, but they don't have anything like a human mind.
And that leaves us with one last, massive question to chew on. Let's say we build an AI that can cure cancer or figure out how to stop climate change just by crunching numbers and following its programming. If it solves our biggest problems, do we actually care if it doesn't truly understand them? That's the puzzle we're all going to have to wrestle with as we build this incredible new future. Thanks for joining me.